Hello everyone, welcome to today's in-depth exploration of the AUC ROC curve. In this video, we'll not only understand the AUC ROC concept but also apply it to a real-world scenario involving our furry friends. So let's get started. In this video, we'll be learning about threshold, true positive rate, false positive rate, AUC ROC curve, its interpretation. Imagine you're building a machine learning model to classify images as either cat or not cat. Let these be the actual value and the values predicted by our model for our testing data. Here, our model has predicted values in the form of probability and not as classes directly. These scores reflects the model's confidence that the image belongs to the positive class. That is, the image is of cats. Now, as a data scientist, you need to make decision of setting a threshold value. For any instance with the prediction score above the threshold is classified as cat, while those below the threshold are classified as not cat. Let us say we have set the threshold to be 0.50. As 0.98 is greater than equals to 0.50, we assign it as cat, and 0.20 is less than 0.50, so we classify it as not cat. Hence, we obtain the following results. Now, we build a confusion matrix to summarize the performance of a model. True positives represents the number of correctly predicted cat images. These are instances that are actually cats and your model correctly identifies them as cat. True negative represents the number of correctly predicted not cat images. These are instances that are actually not cat and your model correctly identifies them as not cats. False negatives represents the number of cat images that are incorrectly classified as not cat by your model. In other words, these are the actual cats that your model misses. False positives represents the number of not cat images that your model incorrectly classifies as cat. So these are the instances that are actually not cats but your model incorrectly predicts them as cats. Now we will learn about true positive rate and false positive rate before we see what is ROC curve. So true positive rate, which is also known as sensitivity or recall, is the ratio of correctly predicted positive instances to the total number of actual positive instances. It quantifies the model's ability to identify positive cases. The formula is as follows: true positive is equals to true positive upon true positive plus false negative. In our case, true positive rate measures the proportion of actual cat images that your model correctly identifies as cat. False positive rate, it is a ratio of incorrectly predicted negative instances to the total number of actual negative instances. So it measures the model's ability to avoid misclassifying negative cases. False positive rate is equals to false positive upon false positive plus true negative. In the context of a cat classification model, the false positive rate measures the proportion of actual not cat images that our model incorrectly classifies as cat. Now, if we think about it, can we improve our model's performance with the same model? Remember, we set a threshold value to be 0.50. What if we change it to 0.10? Let's again build a confusion matrix. In this time, we obtain 5 true positive, 1 true negative, 4 false positive and 0 false negative. This time we obtain our true positive rate as 1 and false positive rate as 0.80. Both the true positive rate and the false positive rate has increased. When the threshold is very low, our model identifies many images as cat, capturing all the actual cats but also misclassifying some not cat images as cats, leading to more false positives. Conversely, if we set our threshold to 0.90 and build a confusion matrix to calculate the TPR and FPR, we get true positive rate as 0.20 and false positive rate as 0. Here TPR and FPR has decreased. When the threshold is very high, our model becomes very conservative correctly labeling not cat images but potentially missing all the actual cats, leading to more false negatives. If we set our threshold to 0.75, we get the following TPR and FPR. Similarly, we can play with all different thresholds between 0 and 1 and identify the threshold which best suits our requirements. But wait, it will become difficult for us to compare the values of all the TPR and FPR. Hence, here comes the role of ROC curve. ROC in the ROC curve stands for Receiver Operating Characteristic. So it provides a visual representation of a model's performance across different threshold values. This makes it easy to compare and assess the trade-off between true positive rate and false positive rate. In the ROC curve, we plot the graph between true positive rate and false positive rate. False positive rate is also known as 1 minus specificity. We know that false positive rate and true positive rate ranges between 0 and 1. So let us plot the values of FPR and TPR for each of the threshold we calculated. As we adjust the threshold for classifying images as cat or not cat, we get different points on the ROC curve. Right. So we observe that at a low threshold, we have high TPR. It is because we catch most cats, but we also have a high FPR because we wrongly classify some non-cats as cats. As we move the threshold toward the middle, our TPR decreases as we miss some cats, but our FPR also decreases as we make fewer false positive directions. So the ROC curve showcases this trade-off, helping us choose the threshold that best suits the model's objectives. The AUC is the area under the ROC curve. It provides a single, comprehensive metric to assess our model's classification ability. It quantifies the overall performance of a model. Here's how to interpret AUC. AUC of 0.5 is equivalent to random guessing. The model is no better than random. AUC is equals to 1 means perfect model with no false positives or false negatives. The model can perfectly distinguish between positive and negative cases. AUC is greater than 0.5 means the model is better than random. The model has some predictive power. AUC is equal to 0 meaning the model would predict all the negatives as positive and all the positives as negatives. A model that performs well will have a curve that bends sharply towards the upper left corner of the plot. So what does this AUC value mean for our cat classification model? A higher AUC indicates better performance, suggesting that our model is effective in classifying cat and not cat images. If we had multiple models, we could compare their AUC values to determine which one performs the best. In conclusion, the AUC ROC curve is a powerful tool for evaluating classification models. Thank you for joining us. Until next time, keep exploring the world of machine learning and data science.